In September 2017, an earthquake measuring 7.1 on the Richter scale hit Mexico, near Mexico City. 44 buildings in the capital collapsed. Hundreds of others were very badly damaged, and many had to be demolished. Insured losses were expected to total $2 billion. Incredibly, one 225-meter-tall, 55-story building stayed standing. How? It was designed to. Torre Mayor, built in the heart of an earthquake region, is one of the tallest buildings in Mexico City. Engineer Enrique Martinez Romero explains what is unusual about earthquakes in the region.
In Mexico City, we have a very long duration earthquakes with long shocks.
As buildings in Mexico City are at risk of being exposed to longer earthquakes, they need to be more resilient than those in other vulnerable regions. Using computer models, engineers carried out a detailed risk analysis to assess the specific threats and hazards posed by earthquakes on the site chosen for Torre Mayor. They then began testing possible solutions to see how these potential risks could be minimized. So, what preventive measures were taken to ensure that Torre Mayor would stay standing in the event of a disaster? Structural engineer Alan Burden explains that a building is less dangerous if it is lighter.
Sometimes buildings which are very heavy and have a lot of walls or a lot of columns, a lot of thick slabs, are not very good in earthquakes. And in fact, it's very important to keep the weight as light as you can when you're in an earthquake region.
In comparisons with traditional brick, steel offers twice the strength for only a quarter of the weight. Steel was therefore chosen as Torre Mayor's principal material, as a lighter building suffers less damage in the event of a disaster. These X-shaped elements are called shock absorbers. They form a protective, moving skeleton across the structure. Architect Ahmed Rahimian explains how they resist the force of an earthquake, keeping the buildings stable. Torre Mayor was designed as an intelligent building. Its integrated smart systems automatically reduce risk to occupants in the building. A key example are the detectors installed in each of the 29 passenger elevators. In the event of any unusual ground movement, the elevators automatically stop at the closest floor, so passengers can exit safely. City planners, governments, and architects around the world can learn a great deal from Torre Mayor. Although technology can provide warnings about natural disasters, they often come too late for anyone to act effectively. The evidence is clear. Instead, the most effective methods of managing or minimizing risk are those which focus on prevention, such as quake-proof architecture. Although it's not possible to stop earthquakes from happening, the forward thinking shown by the engineers and architects of Torre Mayor prove that it is possible to mitigate the risk and prevent greater disasters from happening.